So the next sort we're talking about is the insertion sort. Uh, this insertion sort is a slight twist on the bubble sort in that we actually aren't splitting up our indices so far. We actually start at the second item, and then we compare the first and second item, for the first round through, to see if they need to be switched. But then what we're going to see here is we actually start the two indices for the inner and the outer loops. All of the sorting, basically, not all the sorting, but many of the sortings use two loops, nested loops. They're always going to start at the same spot, but the second indice is going to work its way down. And so we're going to start at the bottom of the list and keep the bottom of the list sorted as much as possible. So we're going to work, start at the bottom of the list, work down it, then move up the list and work down it, move up the list and work down it, essentially is the way these two work. The cool thing about this is once I've figured out that the bottom list is sorted, I can stop. So I just basically am swapping items down until I find that I don't need to swap anymore, because then I know everything lower is indeed lower. So in the bubble sort, I move everything all the way down from the top to the bottom. And I keep doing that even when I don't need to anymore. If it's already sorted, if the bottom one's already there. This one is a clever enough algorithm that we'll see here in a second. It actually stops once it's already reached the sorted items towards the bottom. So again, let's check this out. So we're going to look at the value. And so the first index starts at item 1, not item 0. And then J is also going to start at item 1, the same places where I starts. And since these are different, we flip-flop them. We go ahead and resort these two because O is less than S. And then J is down at 0, so we're done. We update I and J then to be 2. So J ends up being equal to where I starts. I goes up by 1 each time. So now again, we look at R and S and we say, hey, wait, R and S need to be swapped. And so then J goes down, but now R is after O, so I don't keep going down. J doesn't keep going down. I just go ahead and leap back up to the top. So now in this case, T, well, if I compare T and S, I don't do anything. It's already in order. So I don't keep working down. I just skip to the next one. Now, at some point, we start hitting values that are lower, and it becomes a little bit more intense because now I is less than T, and so J moves down. Oh, I is less than S, so then they swap those, and the J moves down. I is less than R, swap those, and J moves down. And then, I is less than O, so we end up swapping that one. So this sequence, once I get down to the bottom, I stop, but I also can shortcut it if things are already in sorted order. So if I have a lot of low values early on, I don't have quite as many iterations. It still could be, in a worst case scenario, as bad as a bubble sort. But in the average case scenario, many of them should be sorted. And so I should, at least shave off a good chunk of the work compared to the bubble sort. So looking at this one, the great part of this algorithm is it skips a good portion of the list once it's in order. And then it's going to really quickly figure out, hey, if the list is already sorted, I'm just going to breeze right through this. I'm just going to go through the list one time and I'm going to be done. It basically, though, the worst case scenario is when everything is inverted and I end up having to push every single new item all the way down. And then I end up looking a lot like a bubble sort at that point. But it's an improvement on the bubble sort. It's a clever way of being able to essentially march your way up the total chain and be able to figure out, hey, okay, well I'm going to insert this one here. I'm going to insert this one there. And so it's a good algorithm to know about. Another good one to code and practice. Again, I wouldn't march my way through all these videos because you're just going to watch them later on and come back to them, but you can if you want to. But I'd go off and try and code this one right now and see what you can make of it.